Hi, we are going to be working on Module 2, Topic 1 review. With this section, they like to talk about similar triangles. So similar triangles, think of it as you're putting a shape in a copy machine and making it bigger or smaller. They're still the same shape. Can't say that word today. Same shape, it's just that they are either larger or smaller. And we have to prove that. And there are 3 ways that we can prove it. One is going to be side, side, side similarity, meaning all the sides have the same ratio. So it may have got twice as big, so the scale factor would be 2. It may have shrunk by 50%, so the scale factor is 1/2. So, and I'll show you that in a minute. We also could do angle similarity, which means we have 2 angles in both triangles that are going to be the same. So if it's talking about right triangles, both of them are going to have 90 degrees, and then their other angle, one of the other angles is the same as the other triangle. Or we can have a mixture of side angle, side similarity. That little squiggly line means similarity. Okay, and that means we have to have 2 sides that have the same ratio and the angle is in between it. Those are the only 3 they're going to work on it, okay? 3, that's it. They're going to try and trick you with the congruent, so be careful with that. Only 3. Now, scale factor. So we're going to start with the original shape, which is this letter. And when it has a little apostrophe, that's a prime. It means we redid the size. So we either made it bigger or smaller. So what we're looking at is how did I go from this 4 to the bottom 2? So did I multiply? Did I divide? What is it? So if it's multiplying, we know it's getting smaller. So sorry, that was my daughter in the background. Okay, so we know it's getting smaller. So we can take the new shape over the original. Or you can say 4 times what will give me 2. And this is going to be a fraction. Don't say that we're dividing by 2, okay? Don't say it's dividing by 2. So whenever it's getting smaller, it's always going to be less than 1. If it's going to get bigger, it's going to be greater than 1. So here the scale factor is either 1/2 or 0.5. I don't care which one you guys choose. We'll accept it. Okay, the next ones we are going to be proving that the triangles are similar. So remember, similar, it's only going to be those 3 that we just talked about. Side, side, side similarity, angle, angle similarity, or side, angle, side similarity. Okay, first one, I hate it when they go overlapping. So my first thing I'm doing is actually going to draw them separate. I think it's so much easier to draw them separate and then look at what you're going to do. So I'm going to take this first triangle, the small one, 5, 15, and 10. And then the second triangle, 10, 20, 30. And what I'm going to do is I'm going to take the small side and put it over the small side. So 5 over 10. Then the medium over the medium. And then the large over the large. And then I'm going to reduce each fraction. So 5 over 10 is 1/2 or 0.5, 10 over 20, and 15 over 30. So these are all the same fraction. If they're all the same, then we know the sides have the same ratio. So if we started with the small triangle, went to the bigger, we increased it by 2. So our scale factor was 2, or if we decreased it by 1/2. But all the sides were the same. So this one is side, side, side similarity. Yes, these 2 triangles are similar by side, side, side similarity. So justifying your claim, you tell me how you did it and what. Okay, so the next one. So here we see that this angle is equal to this one. So that's automatically means I'm thinking about these 2. because the first one only has sides. And the second piece of information, it has these two. So these two has two angles. Automatically, I know it's angle, angle, similarity. I don't even have to do it, okay? I don't even have to do it. I know they're similar. But if we did need to find out what x is, we're going to do the same thing as what we did before. Small side, or I know this second triangle is not the same, but the small side over the small side, meaning that it's going from the one angle to the two angle, one angle to the two angle. So I'm going to go 21 over x equals the 24 over 16. Whatever you start with first, that 21, that has to be the same on the second fraction. So the same triangle has to be on the same row, okay? And now you're cross multiplying. So I would definitely have a calculator ahead with you. And hopefully if you guys remembered cross multiplying, I'm going to multiply these two together and set it equal to those two. Ah, come on. Okay, so I'm going to get 24x equals 21 times 16. I am using my calculator. And then you're just solving for x. And x, I'm going to divide by 24. And I'm going to get 14. So x equals 14. And that's all you would do. Now, if you remember again, I hate it when they have, I really don't, it's harder if they are one on top of the other. So definitely separate them. Have paper out when you're getting ready to take the test. It's going to make your life a whole lot easier. So I'm going to have I'm going to go a little bit different. I'm going to do my large triangle first. And then I'm going to take my small triangle. So I can see my large one is 5. And the large one is this whole length. So that's 6. Now my small one is the x and the 5. And we can always say height over height equals length over length, or small side over small side, long over long, whatever works for you. I'm going to do 5 over x, and then 6 over 5. And cross multiply. So we're going to get 6x equals 25. Divide by 6. X, and get your calculator out. And now that we're in IM2, some of our answers are going to be decimals. Some are not. Oh, 25, sorry. Wow, that was a quick check. 5 times 5 is 25 divided by 6. Even I make mistakes. So 4.1666666. And you put a line just repeating, or just say it's 4.16, or I would accept as 4.2. Okay, round it, make it easy for yourself. And that is Module 2, Topic 1. So go ahead, make sure you know how to do all these. Take the quiz, and good luck.